Welcome to The Explainer. Today, we're diving into something you probably interacted with this very morning without giving it a second thought. I mean, you pour it in your coffee, splash it over your cereal, it's in the cheese on your pizza, and it's the butter on your toast. Cow's milk is literally so embedded in our global food culture that it barely even registers as a choice anymore, right? It's just the default. When we say milk, we automatically mean cow's milk, kind of like how egg always implies a chicken egg. But when you really stop and think about it, there is a massive biological and historical mystery sitting right there in your fridge.
Okay, so let's dive right into this. There are more than 5,000 species of mammals on this planet, and by definition, every single one of them produces milk to nourish their babies. So why, out of thousands of incredibly diverse milk-producing animals, did one very specific bovine species become the universal dairy animal? Do we even drink other animals' milk? If we do, which ones? And why are the vast majority of animal milks literally never consumed by humans at all? To solve this whole mystery, we can't just look at farming. We've got to look at biology, economics, and some surprisingly huge decisions made by ancient farmers thousands of years ago.
Because here is the core thesis we're going to unpack today. Cow's milk is absolutely not a biological necessity for humans. The fact that it completely dominates our supermarket aisles, that's essentially an accident of history. Its global dominance really isn't a verdict on nutritional superiority. It's actually the product of geographical luck, massive scale, and colonial export.
Now, to truly understand this, we have to start with the biology. The very first thing to grasp is that milk isn't just one single universal substance. It's a highly customized nutritional package. Biologically speaking, it's a complete food produced by mammary glands, specifically designed to contain absolutely everything a dependent newborn needs to grow into an independent juvenile. And because every animal has vastly different developmental needs, evolution tightly calibrates the exact ratios of water, fat, protein, and lactose, which is the sugar specific to milk, for that specific species.
And wow, the differences across species are stark. Human milk sits at about 3.8% fat and 7% lactose. Cow's milk is roughly similar in fat, right around 3.7%, but it's lower in lactose at 4.8%. It's perfectly designed for a growing calf. But compare that to a seal. Seal milk is a staggering 50% fat. Why? Well, because seal pups need to rapidly accumulate a thick layer of blubber just to survive freezing ocean temperatures. Whale milk is super fat-rich too. This calibration means that when we humans consume cow's milk, we're literally consuming a product built for an entirely different physiology. It's exactly why human infant formula has to be so heavily modified, adjusting the protein-to-fat ratios and lactose concentrations just to approximate human milk.
So you really can't talk about milk without talking about lactose. Lactose is a sugar that requires a specific enzyme in our bodies called lactase to digest it. If you don't have lactase, the lactose just passes completely undigested into your large intestine, where gut bacteria basically have a field day fermenting it. That's what produces all that gas, bloating, and discomfort. Now, all mammal infants produce lactase to digest their mother's milk, but historically, once weaning was over, the body just shut down lactase production to save energy. For most of human history, adults literally couldn't drink fresh milk. But about 10,000 years ago, a genetic mutation popped up in certain human populations that kept this lactase enzyme switched on into adulthood. We call this lactase persistence. The geographical distribution of this mutation is absolutely striking. In Northern European populations, lactase persistence is at 90% or higher. Most adults there can drink a glass of fresh milk without a single problem. But look at East Asian populations. It's typically below 20%. In sub-Saharan Africa, it's a mix. You see higher rates among pastoralist groups like the Maasai and much lower rates among agricultural groups. This data maps almost perfectly onto the history of dairying. The populations that kept dairy animals for thousands of years actually developed the genetic ability to digest their milk. It's honestly one of the most clearly documented examples of human coevolution in real time. Humans and their dairy animals changed each other simultaneously in an evolutionary blink of an eye.
But here is where the story takes a super fascinating turn. Lactase persistence isn't actually required to consume dairy, and that's all because of an incredible ancient accident. See, the earliest dairy processing was likely a complete mistake. Just imagine ancient humans storing fresh milk in pouches made from animal stomachs. Well, those stomachs naturally contained residual rennet, which is the enzyme complex that coagulates milk. So the milk naturally curdled into something closely resembling a soft cheese. They quickly realized this curdled milk was edible, it was storable, and crucially, as the whey was drained away, the lactose was drained away right along with it.
Yes, it's absolutely true. Cheese and yogurt were invented long before humans actually evolved the genetic ability to drink fresh milk. Converting milk into a hard, aged cheese, think of a really sharp Parmesan or an aged cheddar, leaves essentially zero lactose behind. This allowed ancient people with complete lactose intolerance to safely eat dairy for thousands of years before that genetic mutation for lactase persistence even started to spread. Dairying was fully established through processed cheese and yogurt first. Drinking fresh milk came way later.
This historical accident totally paved the way for the incredibly diverse global dairy menu that exists right now, way beyond the cow. Globally, goat's milk is actually the second most consumed animal milk. Its fat globules are a lot smaller, making it much easier to digest for a lot of people. Sheep's milk comes in third, boasting roughly double the fat and protein of cow's milk, which makes it the ultimate milk for rich, dense cheeses like Roquefort and Manchego. Then you've got the water buffalo, vital in South Asia, and the actual secret behind authentic, creamy Italian mozzarella di bufala. And high up on the Tibetan plateau, you have the yak. Yak milk sits at over 7% fat, which is absolutely essential for survival in those extreme cold climates. It's famously used to make the caloric powerhouse known as Tibetan butter tea.
And the list keeps going with some truly amazing specialized adaptations. In arid deserts where cattle would literally instantly die, camel's milk sustains life, offering lower lactose and higher vitamin C. Across the Central Asian steppes, nomads ferment high-lactose Mars milk, horse milk that is, into a tangy, fizzy, mildly alcoholic drink called kumis. Up in subarctic Scandinavia and Siberia, indigenous peoples consume reindeer milk, which has an unbelievable 22% fat content. I mean, that's basically pouring pure cream. And perhaps most surprisingly, donkey milk. Because it has a composition incredibly close to human breast milk, it was highly prized in ancient Roman Greece, historically used for wet nursing and even high-end cosmetics for skin health.
So, if reindeer milk is like cream and camel milk is a desert superfood, we have to pause and ask the really big question. Out of those 5,000 milk-producing mammal species, why do we humans basically limit ourselves to about a dozen? Why not the other 4,900? Well, the answer is what we call the domestication filter.
To get milk, you have to keep an animal close, manage its breeding, and handle it every single day. Most animals simply do not pass this filter. We can call them the unmilkables. Take the lion, for example. Lion milk is super rich and fatty, but trying to operate a lion dairy farm is, well, obviously a terrible idea. Elephants? Just way too dangerous to approach when they have calves. In Scandinavia, they actually tried milking moose because the milk is so high in fat, but they're just too hard to manage at scale. The zebra is fascinating. It's biologically so close to the horse, but its extreme hardwired fear responses make it completely impossible to domesticate. People have literally tried and failed for centuries. And the kangaroo? Its milk is biochemically brilliant. It literally changes composition from one teat to another depending on the joey's developmental stage. But again, they're completely undomesticated and impossible to manage for human agriculture.
So the crucial point here is scale. This is exactly why the cow conquered the world. A single well-managed, high-producing dairy cow can produce a staggering 10,000 liters of milk per year. Compare that to a goat at roughly 800 liters or a sheep at just 400 liters. The volume difference is just astronomical. You see, when early European civilizations began building large, settled agricultural populations, they needed massive amounts of calories. The cow was the ultimate biological machine for this exact task. Cattle are highly adaptable, they're docile, and they possess this miraculous ability. They can graze on rough pasture land that humans cannot use to grow crops, and they convert that completely inedible grass into massive volumes of high-quality milk and meat. In the temperate climates of early Europe, the cow was simply an unbeatable agricultural engine.
Which brings us to the historical timeline of how the cow actually took over the globe. We start 10,000 years ago with that lactase persistence mutation. Then, for thousands of years, beautifully diverse regional dairy traditions thrived all over. Camels in the desert, yaks in the mountains, water buffalo in the tropics. But in the last 500 years, the game changed completely. European colonial expansion didn't just export people and languages, it exported entire agricultural systems. European settlers brought their highly productive cattle-based dairy systems to the Americas, to Australia, and to parts of Africa and Asia, entirely displacing or overriding the diverse local traditions that already existed there.
What this leaves us with is a really fascinating dichotomy. On one side, we have cow's milk, the reigning global champion. But remember, it didn't win because it was nutritionally perfect. It won through a combination of geographical luck, unmatched volume scale, and the sheer force of colonial export. On the other side, we have the alternative milks: camel, yak, donkey, reindeer. These aren't just novelties. They represent brilliant, highly specialized human adaptation. They are true testaments to human ingenuity in extreme local environments, where a cow would never, ever survive. The milk sitting in your fridge right now is just one of a dozen ways humans have figured out how to extract energy from the animal kingdom. It really forces us to ask, if history, geography, or domestication had taken just a slightly different turn a few thousand years ago, what animal's milk would be in your coffee right now? Because somewhere in Central Asia today, someone is happily drinking fizzy, fermented mare's milk, and they think absolutely nothing unusual about it.